Hello guys, today we are going to discuss this problem based on exercise 1.2. So the first question is like statement whether it is true or false, okay? And then we have to see it how it is false and how it is true, okay? So first, for the first question, in Roman number 1 we have every irrational number is real number, okay? So what is real number? We have to know that, okay, real number are the collections of rational number as well as irrational number, okay? Here it is said that any irrational number is a real number, so it is yes or it is true because real number irrational number is a part of real number, okay? So from that point simply we can understand that it is true, okay? Then we are going to move it in number 2. So in number 2, Roman number 2, every point on the number line is of the form root over m, where m is a natural number m, okay? So any point on the number line is of the form root over m. So whether it is true or not, we have to see it, okay? So here, no negative number can be the square root of any natural number, okay? So if you square negative number, so negative number is not included in natural number, okay? But it can be square root, okay? So but it is not a natural number, so because of that this given statement is false, okay? Then let us move to the last point, okay? Roman number 3. So in Roman number 3, what it is given, we are given with every real number is an irrational number, okay? Any real number is an irrational number. So let us take an example. 2 is real number, but it is not irrational number, it is rational number, okay? So from that we can understand that any real number is not an irrational number, okay? So that's it. So everyone is understand? Okay, let me discuss one more. This number 3. Every real number is an irrational number. So real number, we have to see it. Any real number is an irrational number, okay? So real number are the collections of rational as well as rational number. So in real number, there is rational as well as rational number. So the question has access. Any real number is always irrational number, okay? So we have to see that. From that, we can see that. Let us take some example. That is 2. So 2 is real number and 2 is rational number, but it is not an irrational number, okay? So from that, number 3 is false. Then let's move to this question number 2, okay? In question number 2, what it is given, we are given with are the square root of all positive integers irrational, okay? So what are integers? Integers are the combinations of negative as well as positive numbers including 0, okay? So all these are falling under the term integers, okay? Let us take positive integers. So positive integers are 1, 2, 3, 4, 5. So let us take 4, okay? So 4 is a rational number, okay? So let us take 4. So here, let us assume 4. Root 4 equal to how much? 2 square, okay? So the question has access. Are the square root of all positive integers is irrational, okay? So here it is positive integers and we square it, okay? Then we got this 2. This is not a rational, this is rational number. So this is an integer, we square it, okay? According to question we did it. This is integers, we square it, we put it some root, okay? Then we square it, then the outcome is real number. The outcome is also real number, but it is rational number. So the given statement is false and we wrote it no, okay? So that's it. And in question number 3, we are given with look at or show that root 5 can be represented on the number line, okay? So actually it is similar question like look at root 2 or root 3 on the number line, okay? So here we are going to look at root 5 on the number line. So firstly we are going to do it likewise. Let us consider unit square OABC, okay? OABC of each side 1 unit, okay? So here we made some square, that is we name it as OABC, okay? Or ABC, and then again, so from that we're going to take any one of this triangle. So this triangle is OAB, okay? So you are taking this triangle. So from that we're going to apply Pythagoras theorem. So likewise, each side is 1 unit, so that is, if we square this and if we add this, then we will get 2. Okay, so OB equal to how much? 2. So you move square on the side, that it will become root 2 unit. Okay, then we have to actually we already did this one, okay, in the discussion that we just did it right now. So actually it is a square, so we join this one and we find this as root 2. Okay, so by using this we have to find this triangle or BD. Okay, so here it is root 2, here it is 1. Okay, so by using Pythagoras theorem in triangle OBD, we got root 3. Okay, by using Pythagoras theorem in triangle ODE, we got these values. Okay, so the values that we got here, we have to use it in the next step. Okay, and the values that we got here, we have to use it in next step in order to find root 5. Okay, so you may think that why it is root 4. Root 4 can be broken. Root 4 can be broken into square root of 2. Okay, but actually it is true, but here for this purpose actually we are going to find root 5. But if we break this, then it will become root 2. Okay, but we can't get if we break this, then it will become 2, but we're not able to get root 5. In order to get root 5, we just keep it as root 4. Okay, so that is the reason why we write root 4. Now let us construct, or let us represent this root. Okay, first, in order to represent root 2 on the number line. Okay, so how to do it? So let us take this one and let use compass. Okay, using compass, we have to put that compass in this, and we have to fix pencil here. Okay, then we have to draw an arc, the point where the line, this line and this arc intersect. Okay, this point will give or will represent root 2 on the number line. Likewise, even in this process, you have to put compass here, and you have to fix pencil here. Then you will have to draw an arc, and the point where this arc as well as this line intersect will represent root 3 on this number line. Okay, likewise, even in this process, here it is root 4. Okay, in root 4 you have to draw an arc from here. Okay, by using the same process, you have to place compass here. Okay, and you have to put pencil here. Then you have to draw an arc intersecting the number line. So the given point, or the point where this arc as well as the line intersect this. Okay, so that point will represent root 4 on this number line. Okay, likewise, even in this, okay, we have to proceed it in the same manner. So here let us keep compass, and here let us put pencil. So let us draw an arc, so for intersecting this number line. Okay, the point where this arc as well as this line intersect. Okay, that point represent root 5 on this number line. Okay, so what is this point? We just name it as point S. Okay, likewise, you have to do it. Okay, you have to represent root 5 on or any root values on this number line. Okay, that is easy. So if you have any confusions, or if you have any problem in understanding this, then you can ask me in comment sections. Okay, then we have to state it, or we have to write how we proceed, or how we did this one. Okay, so we have to state how we did that. Okay, so here let us write by using compass. Okay, we use compass and taking OS center, so we have to write, or we have to point at O and using S center. Okay, and OF as radius. So by using OF as radius, we draw an arc intersecting the number line at point S. Actually, we're going to deal with root 5, or we're going to look at root 5 on the number line. So actually we will do it for usually for root 5 itself. Okay, so for that reason only we are taking OF instead of taking so many numbers or so many sides. Okay, like OD, OB. Okay, instead of that we are taking O5, because here we are going to deal with root 5, or we are going to look at root 5. Okay, so after that we draw an arc intersecting the number line at point S. Okay, so from here we draw an arc intersecting the number line at point S. Okay, then root 5 correspond to the point S, hence S represent root 5 on the number line. So root 5 is represented on the number line by this point S. Okay, so likewise you have to do it in case of representing root 5 or root 2 or root 3 on the number line. Okay, So if you have any kind of confusions regarding all these things, comment down below. Okay, then that's all for today. Thank you all my viewers, wish you all the best. Okay, that's all for today.